Bismillahirrahmanirrahim. Welcome to lecture number 15. Today's topic is DDR DRAM. Um, Actually, we will discuss DRAM, we will discuss SDRAM. So this is the before this topic we discuss DRAM and SRAM, and then we discuss SRAM in detail, and then we discuss some ROM technologies. So today we are going to revisit DRAM, and within DRAM we have further three types, that is SDRAM and DDR SDRAM. And the current architecture, the current computers, they are using DDR technology. But in order to understand DDR, we need to understand DRAM and SDRAM. So advanced DRAM organization, or simply DRAM. So this is what you see: SDRAM, DDR DRAM, and RDRAM. So one of the most critical system bottlenecks when using high performance processor is the interface to main internal memory. This is the bottleneck because we need to put data closer to the processor, but that's not possible because of the expensive hardware circuitry for cache and registers. So that's why RAM or DRAM is an important internal memory, but it can become a bottleneck in the processor performance. Traditional DRAM chip is constrained both by its internal architecture and by its interface to the processor memory bus. A number of enhancements to the basic DRAM architecture have been explored. The schemes that currently dominate the market are SDRAM and DDR DRAM. This is what we discussed before. So SDRAM, so DRAM, we discussed the structure of DRAM in previous lecture, but here we are talking about synchronous DRAM or SDRAM. This is one of the most widely used form of DRAM, and it exchanges data with the processor synchronized to an external clock signal and running at the full speed of the processor memory bus without imposing wait states. With synchronous access, the DRAM moves data in and out under control of the system clock. The processor or other master issues the instruction and address information, which is laid by the DRAM. The DRAM then responds after a set number of clock cycles. Meanwhile, the master can safely do other tasks while the SDRAM is processing. So these are just basic definition of SDRAM. This is what the architecture of 256 megabyte SDRAM look like. So this is our memory cell. This is memory cell, and it's 4 megabyte by 16, and in total it becomes 256 megabyte. Okay, so but there are other components that are required to access this memory cells. Like for example, these are the command decoder and clock generator. This is mode register. This is row address latch, and this is column decoder. And these are the column address latch and burst counter and column address buffer, because memory is accessed by two techniques. One is using row address and the other is column address, and all these operations are performed in bank control logic, which then allow us to access the memory, and then we can perform the data in and the data out, and both of these data are stored in these buffers. So this is the internal structure of SDRAM, and you see it's more complicated than a simple DRAM cell. There are multiple pins. You see these pins are here, A0 to A12, and then these are some control signal. So the explanation of these pins and the control signals are given here. You can read this. This is the SDRAM retiming. The burst length is 4, and latency is equal to 2. So these are the clock cycles at time t0, time t1, time t2 up to time 8. Then we have a command read operation, and since the latency is 2, so the next 2 cycles this read takes, actually this read is executed, but we do not have any other operation, and then the read is performed, and then the burst length is 4. So you see this is D out A0, A1, A2, A3, and then when this operation is completed we move to T7. So SDRAM is an important memory architecture, but DDR, double data rate SDRAM, is most commonly used because of some advancement. What are these advancements? So actually this DDR was developed by JE Tech, Solid State Technology Association. Numerous companies make DDR chips which are widely used in desktop computers and server, and these are the 3 factors that help us to achieve higher data rate. First, the data transfer is synchronized to both the rising and falling edge of the clock. Here you see it's synchronized only to the rising edge of the clock, but in the DDR it's synchronized to both. It's synchronized to the rising edge and it's also synchronized to the falling edge. So this is one thing. Second, DDR uses higher clock rate on the bus to increase the transfer rate, and the third, the buffering scheme is used. So DDR, the current that you see here is DDR4, but in the latest architecture DDR5 is used. So this is DDR1. The prefetch buffer is 2 bits, the voltage level is 2.5, and the front side bus data rate in megabits is 200 to 400, and DDR2 and then DDR3 and DDR4, and you see the improvement, like the prefetch buffer size is 8 bits, the voltage level is decreased, and the bus data rate in megabits is it's possible to 2133. So actually it's 2 to 4 gigabits per second in DDR4. This is the architecture of DDR. So actually this is your memory array, and the memory, this is the different circuitry that are used to access this RAM. So multiplexer, and then these are the I/O. This is for SDRAM. So for the SDRAM is the memory array for 100 to 150 megahertz, and the I/O, and then this is DDR, simple DDR, DDR1 with the memory array and multiplexer. DDR2, memory size increases. DDR3, memory size double to the DDR2, and DDR4 double the size of DDR3. And the I/O can be performed at 667 to 1600 megahertz per second. So these are the different DDR generation. There are more videos that you can watch here. Today's lecture was short, but I will share with you some papers that are related to the current study. We need to understand this architecture. We don't need to understand the architecture of the internal memory from the electrical engineer or from the electronics perspective, but we need to understand this internal memory architecture from the computer science perspective. That is, how do we access data from the RAM, how do we store data in the RAM, how the instructions are actually the instruction address and the data address is actually translated to be stored in the RAM, how the data is loaded from RAM to cache, and then how the data is loaded from cache to register, and how the data is written back to the cache or to the RAM or eventually to the HDD. Thank you for watching.